Hi students, let's solve this interesting question together. In this question, as you see a tube which is thermally insulated. So which means that according to the question, there is a no heat that can go out of the system as well as there's a no heat that can go inside the system. Okay. So it means that there is all the energy changes that will happen will remain inside this system. Okay. And this tube is filled with n number of lead spheres, each of mass m. So if n number of lead spheres and each have a mass m, so can I say the total mass should be n multiplied by m? That is a total mass of all spheres. And according to this question, what we are doing, we are inverting this tube. For example, if this is a tube, so we are inverting this tube like this. So when we are inverting this tube like this, so these lead sphere is covering average displacement or distance equals to distance L. And during this, of course, there will be some energy change will happen. Potential energy will convert into kinetic, and then kinetic energy will convert into the thermal energy. Okay. Due to that thermal energy, the temperature change has been observed, that is delta T. Okay, so we have to find out specific heat capacity of lead. Okay, it seems complex question, but when we will break it down into the easier steps, you will understand, and I will explain you with the help of diagrams. Okay, so let's first of all go to the definition of specific heat capacity. So we denote it with letter C, we represent it with letter C, and the specific heat capacity is the specific amount of heat required to raise the temperature of 1 kg of substance by 1 Kelvin or 1 degree Celsius. Okay, you must remember that what is a formula in our IB curriculum, that is MC delta T. So we can find out C from here, that is Q over M delta T. Now, this M means that the mass of a one lead sphere, but if we have to represent the all the mass, so that is N M delta T. Okay. Now, after this, it's very interesting. Okay. Now the question is that from where this heat comes from. So students, this heat comes from the work done on all lead spheres. Okay, so in the context, I'm writing that the work done is always equals to change in energy. It can be change in any energy. So for this specific question, this is change in thermal energy work done, right? Now how it will happen, so let's take only one sphere case in the diagram. So students, you see that in this tube, this is the one lead ball which has a mass m. Okay, and what is the distance according to the question? It is the capital L. So when we will invert it, okay, of course you will apply some mechanical energy to do that. As a result of that, it will gain the potential energy. Why? I show you. So before inverting this, there was a no work done, 0 joules. There was a no energy of the system of this lead ball. But now when the lead ball has a distance L, don't you think that now this lead ball must have the gravitational potential energy, and that is actually due to the work done, and the same gravitational potential energy will convert into the thermal energy. But we have a large number of lead balls, so what will be the total gravitational potential energy stored? So for this we should multiply the total number of balls nmgl. Okay, now this is a total amount of gravitational potential energy stored, or you can say in other words the work done, that will appear in the form of energy stored in all of the balls in the one inversion, like one time inversion. But according to the question, please pay attention that we are inverting s times. So for s times, it can be 10 times, 20 times, or 100 times. Okay, so it means that in every turn there will be some energy, nmgl energy will be stored. So what will be the total energy stored in s times inversion of this? That should be snmgl. So now I'm going to put this thing here, okay, because that is the ns and mgl is the energy that will appear in the form of heat, because there's a no energy lost. Okay, so we are going to put the values here over nm delta t. Delta t is a change in temperature, so nm and nm is cancelled out, and finally our answer is sgl over delta t. So that should be option B. I hope you understand this solution.